Hey guys, Mr. B here. I'm going to take you through a couple of examples now of solving log equations. And if you remember from class, we looked at basically two different cases. So the first case is when you have sort of a log on both sides of the equal sign. And the second case is when you have a log equal to a number. So I'll take you through both cases. But what you have to remember for both cases is that you still have to use your rules of logs to be able to solve these guys. So let's have a look and see. So there's not much we can do with this guy over here. He's pretty much simplified as much as possible. But we do have a couple of things going on here. We have a number outside of a log. So if you remember, anytime you have a number times a log, you can take that number and put it to the exponent of anything that's inside the log function. So let's rewrite this guy. So log 3 to the x. And if you remember, anytime there's nothing there in terms of a base, it's always 10, equal to log 4 to the 1 over 2 minus log of x. And if you remember, anything exponent 1/2 is the same as square root. So log 3 minus x is equal to log of 2 minus log of x. Now we have to use our rule for subtracting logs. So the way I remember my log rules is I think of my exponent laws that we know so well, we've been doing since grade 9. And the exponent law that goes with this one is that if you're dividing powers with the same base, you subtract the exponents. Well, for logs, it's the opposite. For logs with the same base, when you subtract them, you divide what's inside the log functions. So when you're subtracting logs, you divide, and when you're adding them, you multiply. So log 3 minus x is equal to log of 2 times x. So there's no need of writing, you just multiply what's inside, or sorry, I made a mistake, you should divide that. You just divide what's inside the log functions. So 2 divided by x. So that's as simple as it can happen. A little mistake like that, you gotta stay focused there, guys. Alright, so once you get to this step, it's a thing of beauty, really. You have to just simply let what's inside the log functions equal to each other, because the only way that these two things are equal if what's inside the log functions are equal. So it sort of goes back to what we did with common bases and exponents. The only way that if you have exponents that are equal, so an example would be like 3 to the 2 x is equal to 3 to the x 2 minus x. The only way these things are equal is if the exponents are equal. So we used to think of it as just get rid of the bases and let the exponents equal to each other. Well, it's kind of the same thing with logs. We just get rid of the logs and let what's inside the functions equal to each other. So now once we get here, we can usually, for this type of case, we can usually maybe cross multiply, that kind of thing. So I'm just going to take this x up here and multiply this guy. So it's going to be x times 3 minus x is equal to 2. And then I'm going to have 3x minus x squared is equal to 2. And you guys know how I feel about like having a negative in front of the x squared. I usually like to have it positive, so I'm going to take everything across here. So 0 is equal to x squared minus 3x plus 2. So once you reach this step, you usually have a quadratic of some type. You can either use quadratic equation or factor it. I'm just going to use the AM method. So it adds to get -3 and multiplies to get 2. Well, the answer is -1 and 2. So x minus 1 and x minus 2 is equal to 0. So this is the factored form of this guy. And now so my solutions are x equals 1 and x equals 2. So those are my two solutions. So always check to make sure they work, and you can do that just by subbing it back in here if you want to, or graphing this guy. But we also have to verify that they are actually solutions. So if we go back to our original equation, we look at, is what's inside my logs less than 0? So 3 minus 1 is 2. That's good. 3 subtract 2, still good as well. So you got to make sure that what's inside the log function is greater than 0. All right, because a log function can't be less than 0. All right, so these are both solutions, so we don't have to reject any of these. But sometimes we might end up with a negative in here, or something that makes it not a solution. So we have to check. They're both good, so both are solutions. All right, let's have a look at the second case here. And that's when you have a log equal to a number. So you see on this side we only have 2, whereas before we had, everything was log, and it worked down to be log of something equal to log of something. And this time we have base 3. So we're adding logs here initially, so we have to multiply this time. So I have log of 3, 4x plus 1, and x minus 2, and that's equal to 2. So at this step, some of you guys are always, as soon as you see you have to FOIL something out or distribute it out, you're always eager to change it right away. I'd wait in this case and just do it in the next step. Well, what you got to realize is that we got log of base 3 of this is equal to a number. So the only way to solve this is to convert to exponential form. So that's kind of what you have to do when you have this case, the second case here. So remember, to convert to exponential form, the base of our log is the base of our exponential. Whatever that log is equal to is the exponent. And then what's inside the log function is what our exponential equals. So 4x plus 1, x minus 2. So now we can FOIL it out, and it's not so compressed. It's not inside the log function, so it's not such a hard process. So I'm going to have 4x squared minus 8x plus x minus 2. Then to go for another further step, 4x squared minus 7x minus 2. Then I'm going to take this 9 across, so I'm going to be left with 0 is equal to 4x squared minus 7x minus 11. So I'm going to use quadratic formula on this guy just to take you through an example. And hopefully I did everything right so far. X is equal to negative b plus or minus the square root b squared minus 4ac all divided by 2a. Hopefully you won't forget that guy in your final exam. So that's a negative b, so negative 7 is going to be a positive 7. Then 7 squared, negative 7 squared, minus 4. This guy's always going to be positive. Minus 4 times negative 11, all over 2 times 4. So let's see what works out underneath this. 49 minus 4 times negative 11. So it works out to be a really good number, 225. And then this guy's 8. So square root of 225 is 15. So 7 plus or minus 15 over 8. So remember how this works with the quadratic formula. And when you have the plus or minus, you have to do the plus part and you have to do the minus part. So 7 plus 15 divided by 8. And then 7 minus 15 divided by 8. So we got 7 plus 15 divided by 8 is 2.75. 7 minus 15 divided by 8 is minus 1. So you go back now, you look at your solutions, you're hoping that you don't have to reject any of them. So we go back and look, and if you look, we put 2.75 in here, we're okay. That's okay, because 2.75 subtract 2 is positive. But if you put the minus 1 in there, minus 1 subtract 2, well, that's going to be, we reject this root. That's going to be less than 0, so we reject it. But this one's okay, 2.75. So I'm going to check this just to make sure it's okay. Doesn't seem like that's a really good number, but I just want to be sure. So what you can do to actually check one of these solutions is I can actually evaluate just by subbing my solution into here, 2.75. So let's see, 4 times 2.75 plus 1, that's 12. And then that's log of 3, 12, plus log 3 of 0.75. And we're wondering what's that gonna equal. So let me actually, can I drag this whole thing away? Let me drag it down here so I can show you something. So if I want to actually find the value of this, I can't do log base 3 on my calculator, but I can do log base 10. So I'm going to convert all this in terms of log base 10. So if you guys remember the formula, it's just log of 12 divided by log of 3 plus log 0.75 divided by log of 3. So it's just basically log of whatever divided by log of the base, and then log of 12. So then you can just take your calculator out and actually compute it. Log of 12 divided by log of 3 plus log 0.75 divided by log of 3 is equal to, when you do the math on that, I just subbed it right into my calculator, I got 2. So you can actually check that answer, and we got a correct answer here as well. But you'll notice if you tried that with -1, you wouldn't actually be able to compute this part right here because it will be less than 0. And it's just outside the range, outside the domain of the log function. Okay, so that's how you do that, guys. Be aware of those two cases. Practice. Alright, thank you very much. I'll see you in class.